Hi, hello everyone. Myself Priyanka Pise, lecturer in Electrical and Electronics Engineering Department, Jain Polytechnic, Belgavi. The video is mainly based on basic electrical and electronics engineering subject, which is allotted for second semester mechanical diploma students. This video is mainly based on Unit 6, that is electronic component and its applications. So we'll see what are the contents will be covered in this video are diode, half wave and full wave rectifier, Zener diode as a voltage regulator, and logic gates. So moving to the first concept, it is diode. Diode is nothing but it's a semiconductor device with two terminals which allows the current to flow in only one direction. So one type of diode which is shown here, it is a semiconductor device which is having two terminals. These are nothing but anode and cathode terminals. Anode is said to be positive and cathode is said to be negative terminal. So one practical type of diode is shown here. So how to identify the terminals of the diode? So in case of diode, there will be one silver coating on that diode. It is said to be cathode terminal and one more is anode terminal. So diode works in only one direction. So diode allows the current to flow in only one direction. It is called forward bias condition. And in one more bias condition is there. It is called reverse bias condition. Under this condition, diode will not be working. It means it will not be allowing the current to flow through it. So there are number of types of diodes are available. Those are photodiode, varactor diode, tunnel diode, Schottky diode, PIN diode, laser diode, avalanche diode, Zener diode, and light emitting diode or LED. So what are the practical applications of these type of diodes? We'll see it. There is one image shown here. These are the practical images of the diode. There are number of diodes are shown here. So in first diagram you can see that photodiode. So where do we use this photodiode? These are used in case of alarm circuits. So in next diagram you can see it is a type of diode which is called varactor diode. It is used in regulated voltage controlled circuits. So third one, it is tunnel diode. Tunnel diodes are used in case of oscillators. So next one is a Schottky diode. These are used where as a switch while proper voltage is applied across that diode. So next one is a pin or PN junction diode which is used in rectifier circuits. About this rectifier circuits we'll be studying in the next slide. So next one is a laser diode. Laser diodes are being used in fiber optic communications or laser printers or readers. Also we can use laser type of diode. So last one is the LED type of diode. It is light emitting diode which is used in power indicators and in domestic lightings. So these were some of the applications of the diodes. So moving to the next concept, it is a rectifier circuit. In case of generating stations, the voltage will be in the form of AC. But in some applications, these require DC power supply as an input. So how to convert that AC into DC? It is done by using rectifier circuit. So the rectifier is a electrical device which converts alternating current into direct current by allowing a current to flow through it in only one direction. So there are number of types of rectifiers are available. These are half wave rectifier with and without filter, full wave rectifier with and without filter, and full wave with bridge rectifier. In this video we are going to study this half wave rectifier without filter and full wave rectifier with bridge rectifier and without filter. So first one is a working of half wave rectifier. There is one circuit diagram is shown here. In this circuit diagram we can find out there is one transformer which is connected to the input side. This is the input side of transformer is connected and the secondary is connected to the load through this diode. So diode is used to allow the current to flow in only one direction. So this is the construction of the half wave rectifier. So we'll see how this half wave rectifier works. Under this positive half cycle, this terminal is said to be positive and it is said to be negative. So this positive terminal is connected to the anode terminal of the diode and negative is connected to the cathode terminal of the diode. So diode under this positive half cycle is said to be, it is in forward bias condition. It means it will be acting like a short circuit. So output will be appearing across this RL. So it is the output waveform under this positive half cycle. When it it comes in negative half cycle, so the terminals or the polarities of the input will be reversed. So it will be negative and it will be positive. As we know that under reverse bias condition, it means whenever this negative is connected to the anode and positive is connected to the cathode, at that time diode is said to be in reverse bias condition. So in reverse bias condition, diode works as a open circuit. So it will not be conducting. So there is no current flowing through this load resistance. So the output across the output resistance is 0 under negative half cycle. Whenever it reaches to positive half cycle, again there will be a output appearing across the load. Whenever it reaches to the negative half cycle, there will be 0 appearing across the load. So it was the working and construction of half wave rectifier. So moving to the next concept, it is full wave bridge rectifier. So full wave bridge rectifier is having 4 number of diodes which are connected in such a way that it makes it as a bridge circuit, and one load resistance is connected here between those 4 terminals and the input is connected here. So this is the input waveform and this is the output waveform which is appearing across this load. So we'll see how this full wave bridge rectifier works. Under positive half cycle, this terminal is said to be positive and this set terminal is said to be negative. So if D1 and D4, anode of D1 is connected to the positive and cathode of D4 is connected to the positive, it means diode 1 will be in forward bias condition and D4 will be in reverse bias condition. So diode 1 will be like a closed circuit, and some here D2 cathode terminal of that D2 is connected to the negative and anode terminal of that D3 is connected to the negative. So D2 will be in forward bias condition. So under positive half cycle, D1 and D2 will be in forward bias condition. Remaining diodes will be in reverse bias condition. So how current will be flowing through this load resistance? We'll see. It will be from this diode 1 to the load resistance. It will be from and it will go to the D2 and it is back to the supply. So in this direction the current will be flowing through the load. So output will be appearing across this load which is shown here. Now under negative half cycle, this terminal will become negative and this terminal will become positive. So cathode of D4 is connected to the negative and anode of D4 is connected to the negative. As we know that D4 is in forward bias condition and D1 is in reverse bias condition. So if I come to this positive terminal, so D2 anode terminal, a cathode terminal is connected to the positive and cathode terminal of anode terminal of this D3 is connected to the positive terminal. So D3 will be in forward bias condition and D4 will be in forward bias condition, and remaining these two diodes will be in reverse bias condition. So these are said to be in open circuit. So how the current will be flowing, we'll see it. So current direction will be from this D3 to the load to this diode 4 and it is given back to the supply. So this is the direction of flow of current. So output which is appearing across this load resistance. Again positive half cycle will come. Under positive half cycle, diode D1 and D2 will be in forward bias condition. Again in case of negative half cycle, D4 and D3 will be in forward bias condition. So it is the output voltage appearing across this load resistance when it is connected to a full wave bridge rectifier circuit. So moving to the next concept, it is Zener diode as voltage regulator. So as we know that Zener diode is a type of diode. Actually it is a special kind of diode. At normal conditions, it allows the current to flow in forward bias conditions. But Zener diode will also allow the current to flow in reverse direction when the voltage is above the critical value or the breakdown voltage. At that time also it will allow the current to flow through it. So there is one circuit diagram which is shown here. It is properly designed to maintain the output voltage as constant. So the meaning of voltage regulator is nothing but maintaining the output voltage constant across the load terminal. So it is the circuit diagram for Zener diode as voltage regulator. So next one is a logic gates. Yes, these are electronic circuits that operate one or more input signals to produce an output signal. So the output signal of a gate is a simple Boolean operator of its input signal, and any Boolean functions can be represented in the form of these gates. So there are a number of types of logic gates are available. It might be OR gate, AND gate, NAND gate, NOT gate, OR gate, NOR gate, XOR gate and XNOR gate. So we'll study one by one the logic gates. So there is one chart which is shown here. So in this chart we can see the logic function, logic symbol, truth table and the Boolean expression. So first gate is nothing but NOT gate. So NOT gate is a inverter. It means it is having only one input and one output. So whenever the input is low, output will be high, and input is high, output will be low. So the Boolean expression for the NOT gate is given as y equal to a bar. So second gate is a AND gate. AND gate is having two inputs, A and B. Y is said to be output of that AND gate. So the output of the AND gate is high whenever both the inputs are high, or else the output will be 0. So the Boolean expression for this AND gate is given as y equal to A dot B. So the next gate is NAND gate. So NAND gate is an inverted form of this AND gate. It means the output of the NAND gate is low whenever the inputs of the NAND gate are high. So the Boolean expression for this NAND gate is given as y equal to A dot B whole bar. So the next gate is OR gate. OR gate is also having two inputs as A and B, and Y is said to be output of that OR gate. So we can see here that input, when both the inputs are low, at that time output is low, or else it will be high. So the Boolean expression for this OR gate is given as y equal to A plus B. So the next gate is NOR gate. In case of NOR gate, it is also having two inputs. It is the inverted form of OR gate. It means the output is high whenever both the inputs of these NOR gates are low. So the Boolean expression for the NOR gate is given as y equal to A plus B whole bar. So the next gate is a XOR gate. XOR gate is also having two inputs and one output. The output of this XOR gate is high whenever either of the input is high. And XNOR gate is a inverted form of XOR gate. So output is low whenever either of the input is low. So these were some of the logic gates types. So we'll see where do we use these logic gates. These are being used in case of heating elements or heating applications. You all might have used these heating applications. In heating applications, automatic power off should be there. Okay, so to make that heating element automatically off, we are using one type of gate here. It is called NOT gate. So NOT gate is used as a temperature detector. So if the temperature of that heating element will become more than 20 degree Celsius or set value, the heating element should be switched off. It is done by this NOT gate. If the temperature of that heating element is less than 20 degrees Celsius, then heating element should be switched on. So this is one type of practical application. And in next case, we can see that there is one doorbell example is given here. So there are two inputs are given to the gate. It is called OR gate. So there are two inputs are nothing but front doorbell switch and back doorbell switch. As we know that output of the OR gate is high whenever either of the input are high or both the output are high. So if either the front bell doorbell switch or the back doorbell switch is pressed, then doorbell rings. So this is one type of application of OR gate. So there are number of applications of these logic gates. Those are used in microprocessors, microcontrollers. These are used in case of embedded systems, and these are used in case of electronic and electrical circuits. So I hope you have understood all the concepts which we have discussed in this video. So thank you so much.